each day, but always try to be present in the live sessions. I think that is more efficient because if we are having any kind of questions or something, we can ask you can ask it at the right moment. Okay. So even though there is the record sessions are available, always try to be present in the live sessions. So can you see my screen?
Yes, sir.
Yeah. Okay. Thanks. Yeah. So today our very beginning session, our very first session. So we are not directly going to the software side, but to learn BIM and the application of BIM in facade and how to model the facade elements using Revit. Yeah. So before directly going to Revit software, we should have some basic knowledge and basic concept of the BIM. So that is something we are going to cover today. So may I know, yeah, let's try to make this session something interactive rather than I'm speaking everything and you are sitting and listening everything. So at least you might have some, yeah, at least you might have heard about BIM or something like that. So
Yes, sir.
what is your understanding about BIM? Mm, or why
Ac-
you are opted for these BIM courses?
Actually, in the facade market,
Mhm.
if we don't know BIM, so
Okay.
it will be it is not same like before. Before we was CAD was enough for the facade. Now it's very hard to coordinate with all contractors, and
Yeah. Yes. Yes.
in the BIM there is every contractor access, and we can work together. We can find the classes,
Yeah. Okay.
and we
Yeah.
can make
Yes.
our work is
Yeah. So that makes sense. Yeah. So okay. So BIM is yeah. So in short, BIM is nothing but it's actually a process like we are replicating the mm, whatever whether it's not only applicable to the facade industry, but it's BIM is everywhere. It's applicable for the whole construction industry, like
construction.
architecture, structure, and MEP, and even in other industries also, like the automobile and all industries, using the using the benefits of BIM. So what we are actually doing is we are creating a digital replica or a digital representation or a digital model of the original, the real asset. Asset means the real, it can be a building or it can be a road or bridge, anything, it can be anything. So we are creating the whatever we are creating on the site, we are creating a digital version or we can simplify the term, we are creating a 3D model. Mm, so it will be easy to understand. And the model will be having no the not only the geometry, but also it will include the other information also, non-geometrical information. So what are those non-geometrical information? So for example, if there is an equipment, maybe a door unit or something, so it will be having a specific
Information.
manufacturer, and it will be coming with some fire rating, yeah, and some other technical values, or yeah, it will be having specific warranty period. So in a normal 3D model, we cannot add these kind of information. We can show only the model. But when it is BIM, these informations also will be there within the model. And that is what we are doing in Revit. We'll be creating the 3D models with all this data. So that is actually simply that is the building information modeling or BIM. But it is not just a 3D model. We'll be using the BIM model for in different stages of the project, like from the initial planning to construction documentation and until the end of the life of the building, we'll be making use of this BIM. So that is another leak actually. Anyway, in simply that is the BIM. It's an information rich modeling approach. Okay. Okay. So let's go through the slides. Yeah. So I think you can still see my screen, right? Yeah.
Yes, yes.
Yeah. Okay. So BIM is actually, as I said, yes, actually some people are having a kind of confusion still, like BIM is a software. Some say Revit is BIM, or some say ArchiCAD is BIM. But now it is clear that this is not a software, but this is actually a kind of process which
Yes.
involves utilization of different softwares. So for the modeling and for the data integration, we'll be using Revit, and for clash detection and for coordination purpose, and also for the time-based simulation for these kind of things, we'll be using Naviswork. So in different stages, we'll be using different software. So BIM is actually a process, as we said. So and we know, for a construction, for every construction projects, there will be multi-disciplines like architecture, and there will be the structure, and mechanical discipline will be there, and electrical discipline will be there. So all are collaboratively working each other. So this will make the entire construction process clash free, and uh, and also we can extract, as I already said, we can extract all the necessary data, and everything. So basically, in simple words, BIM is nothing but a data rich model, digital modeling approach, and it indeed help us to make some decision. Like decision means, suppose if the construction is already done, then the maintenance side is happening. Okay. So if there is any issue with any element, from maybe a door element, or it can be a curtain panel. So if there is any issue with any curtain panel or something, so we don't need to physically inspect the element in the real building, but instead we can have a look at the BIM model, and we can check if the element is still under warranty. Then if it is still under warranty, whom we can contact. So all these kinds of information will be there. Yeah. So this already we already explained. BIM is nothing but a data rich 3D model, and we can work collaboratively. Like collaboratively means all the the architectural discipline and the structural discipline, and everyone will be working together. So we can foresee if there are any kind of clashes or something. So it will lead to a clash free site works. Okay. And also BIM supports now if it is just the geometry, we know it's come with 3 dimensions, but BIM comes with some other dimensions like 4D, 5D, and 6D. So 4D means that's the time, and when it's 5D, it's at the cost. and 6D is the facility management or the asset management for the entire life cycle. So BIM adds these dimensions also, not only the conventional 3 dimensions, but the time we
I,
can. Yeah,
I have
please.
one question, sir. What is asset, sir?
Assets means nothing but all the building elements are basically called assets. Okay, a door is an asset, a furniture is an asset, a window is an asset, a curtain panel is an asset. So all the building elements are basically called assets in the BIM terms. Okay, that's all.
Thank you.
So, when you are once you are starting working in a BIM based project, you will frequently hear a lots of technical terms. So we should be at least we should be able to understand what's it. Okay. So we already know what is BIM, and another term that you will hear here and there, that is the digital twin. That is actually the next level the next level use of the BIM. So digital twin means now we have a BIM model. So BIM model, we know, as we know, it's a 3D model with a lots of information, and we are delivering all the construction drawings and the fabrication drawings and everything, and the site work is done. The structure is now real. The structure is now real. It can be, as I said, it can be a building, it can be a bridge or anything. Then comes the magic actually. Then comes the digital twin concept. There are a term that's called Internet of Things. Internet of Things. So uh, we'll be using some sensors, some smart sensors that we'll be installing at key points of our real structure. For example, we will add some temperature sensor or stress or strain sensors in our concrete, for an example. So these sensors will give real-time information. It will give real-time information to the BIM model. So if the concrete exceeds the stress limit or the strength limit at any point, or if there is any chance for the concrete slab to failure, we can foresee it. For example, if the load is increasing more than the limit or something, so we can foresee it in our digital model, and we can do the necessary restoration operations. Yeah. So the BIM plus the smart sensors installed in our real building or whatever it is, or bridge or something. So together they will give us the real time analysis of the current situation of our building or any structure. So based on that, we can predict what is going to happen if there is any repair was needed. Normally, what will happen? We cannot foresee anything. If any failure happens, then only we come to know, oh, something have happened. We need to address it. But um, with the digital twin, we can foresee all these kind of things with the help of sensors. Sensors, we already know what are sensors. Even our mobile phone uses a lots of sensors, proximity sensor and uh, temperature sensors, and it senses uh, our temperature or our proximity, and it's do the task necessarily. Or for example, our phones will automatically adjust its brightness based on some kind of sensors in it. So the same way, we will add some sensors in the building, and which will give the real-time information to the BIM model. So that is done using some advanced softwares, for example, Autodesk Tandem, and some other softwares are there. So that is a digital twin. So that is actually basically the BIM model, which is uh, updated in real time by using of this kind of sensors installed. Okay. So this helps us to predict the necessary maintenance or any what to say or any restoration works or any needed in the future, so we can foresee it before any major issues happening. Yeah. So there is a important term. So we all should know where the industry actually going. Okay, we are detailing everything. Instead of inspecting the actual building, we will check it on the digital model, digital team. And as I said, next term we will be hearing that the IoT. IoT means uh, this smart sensors, and IoT stands for Internet of Things. It's nothing but simply some kind of smart sensors like, as I said, temperature sensors, humidity or CO2 sensors. So, for example, if there is a waiting room or something, maybe we can install kind of CO2 sensors, and if the occupancy increasing more than a certain level, then we can do necessary things to make the CO2 level within limit if there is any air purifier or something. Okay.
This information we can make in BIM.
Yeah, exactly. Not directly in Revit, but Revit will help us to
Through
create a
yes, yes,
create a BIM model, and then
yes,
that is
yes.
the next stage actually. Okay.
Through any plugin softwares.
Yeah, some using some other software.
Okay.
Not a direct part of BIM or Revit modeling. Okay, but we should know the advanced
Yes, yes,
technologies
yes, sure.
yeah, because if someone telling you, yeah, what is this, then we should know, yeah, this is
Yes, yes.
digital team, this is IoT, yeah. So this is actually the concern. This is the direction actually construction industry going. Okay, everything becoming smarter. Then why not the construction
Smart.
industry?
Yes, sure.
Okay, so we have already discussed this, the importance of these sensors in a digital team. Like we'll be getting the real time information from the real building or a real structure to our digital or the BIM model. So it will help us to predict any maintenance needed, and if there is any improvement for for example, if there is any lift or something, if there is any kind of improvement or something needed, we can foresee that, and we can do that. And another important thing, actually, more than uh, the digital tin, these are the very common terms. These are which we should know even while we are modeling in Revit also. Okay. So the very first term is LOD. So LOD stands for level of development. So it's actually level of development is we can model a building in different level of details. We can model a building in like a very simple rectangular thing, and we can model the building with the exact doors and windows, and then we can again refine the building model by adding necessary fixings and everything. So each LODs have kind of different level of detailing. So I will explain that in the next slide. And another one is IFC. This is actually kind of file format which we usually export from Revit. It's something like if you are working in Word, if I send the Word file to someone else, and if they don't have the Word file, what will happen? They cannot open it. So in order
Yes,
to overcome this, we usually send documents as PDF, right?
yes,
So PDF can be opened in many different softwares. Okay, so it's more flexible. So when we are coming back to BIM, it's actually a PDF of BIM. The IFC, IFC is something we can call a PDF of BIM. So if I do something in Revit, if I send the direct Revit file, perhaps the client may not be having the Revit to open it. So if I send IFC, there are lots of free IFC viewers. So they can simply open and they can see the model. They can check the model. And more than we know there are some other 3D format also, but IFC can include the data also, not only the 3D geometry, but it can include the
Data
geometry also.
information.
Geometry and the data also. Data means I already said some will be adding information, the manufacturer information, the warranty information, everything will be adding in the model. So IFC can handle the both geometry and the data. And the next important term is the BEP, and it stands for BIM execution plan. So when you are starting or doing a BIM project, an actual BIM project, the basic guideline of your work will be the BIM execution plan. You will be receiving the BIM execution plan in a form, in a PDF format or something. So it will outline which version of software you should use, and which software you should choose, and the main milestone of the projects, and so all these kinds of things will be outlined in the BIM execution plan. So whatever the BIM project is should be in align with the BIM execution plans. That is actually the Bible of our project. Okay. So the BIM manager will be usually preparing this one, and all the BIM modelers or BIM engineers should adhere with the guidelines which is mentioned in the BIM execution plan. So that's actually a document that drives the overall BIM workflow. Okay. And another thing, I think the next term is Internet of Things, IoT. This we already covered. There's nothing but that is the smart sensors used for the achieving the digital twin. Now we can go through one by one. So the very important one, LOD, level of development. So can you see this small image clearly?
Yes.
Yeah. So if this is actually a metal column section, structural column section. So LOD 100 is actually called concept stage. So at the concept stage, we will be just showing the overall size, not the exact. We will not be modeling with the exact shape, but mm, here, if you look at this image, at the LOD 100, this is the LOD 100 stage. It's just
The
showing the
concept.
element like square. It's not exactly showing the web and flanges. So it's just showing the overall dimensions only, the overall space it occupies. Okay. So if it is a building, it will just show the overall shape or the overall form of the building. If you look at here, it's actually a wall. For the LOD 100, it doesn't show any openings or any construction details here. It's just showing the overall geometry. So LOD 100 is the concept stage, and we will not be showing any details there. So it's actually this LOD actually we will be using at the very earliest stage of planning or the architectural designing, like that. Okay. So as I said, the building execution, we do every project based on the instruction in the building execution plan, and the building execution plan will specify which LOD we need to work. Based on that, we will be modeling our projects. Okay. So the next LOD is LOD 200. That is the schematics stage of development. So we can see the geometry is more defined, we are showing the webs. For example, this is an example, and for the structural column, it's showing the more detailed form, but still the geometry will not be the what will not be matching the exact ones. Like we know for the flanges and also for the webs, there will be some fillets, right? At the corners, there will be fillets. So that kind of very minute details will not be showing, but still the overall dimensions and the overall geometry will be matching the exact one. But the material information will not be there. There will
This
not
one,
be any.
this
Yeah,
is in
please.
LOD
LOD
200.
200, yeah, LOD 200. So
Yes,
in LOD 200, geometry will be little bit uh,
yes, yes.
refined,
It's not
but
exact same.
material
Yeah,
information will not be there.
not
Any
be there.
material
Yes.
specification we will not include any material specification at this stage. And also, if for example, if there is any door or something, we will just show it like an overall extrusion, simply an rectangular extrusion. We will not show it's like a frame and then shutter. Nothing will be there. Okay. Then comes the LOD 300. It's more detailed one. Here we will start adding the material specification for each components. Okay. So the LOD from the LOD 200 and we are transitioning to LOD 300. So, but the main change that we'll be starting to add the material specification for each component, and also that is the main difference. And if there is any door or something, we will add separate profiles for the frames and the shutter and everything. But still, for example, we know if there is a metal door, we all know that the frame profile, we know it comes with a
Yes, there
lots
is
of
frame, there is
components.
shutter.
Yeah,
Yes.
there is a lots of on the exterior side there can be a profile, on the interior side there can be a profile, and there can be
Yes.
thermal
Bottom, there is
breakers.
different profile.
Yeah, thermal breakers can be the.
Yes.
So in LOD 300, we will not draw all this much detailed profile. Instead, but still there will be a different profile for the frame and different profile for the shutter and everything. But we will just drawing the profiles like a rectangle, simply like a rectangle. But no need to confuse a lot at the moment, because once we are starting the actual, we are starting the modeling, everything will be clear. But at least no, there are different types of detailing. Okay. And the next one is the LOD 350. So looking at the picture, we can see from the LOD 350, we will start adding, showing the fixings. For example, in the case of facade, we will start to show the brackets
Escalate.
or the spigot from the LOD 350. Until LOD 300, we will not be showing any brackets or anything. We will just show the mullion, transom, and the panels only up to LOD 300. From the LOD 350, we will start to show brackets and everything. Okay. But we will not be usually showing any bolts or anything. But and next comes the fabrication level detailing, that is the LOD 400. So we will add the bolts and everything, all the holes and everything will. So it's actually the fabrication level of detailing. From if you want to create a fabrication drawing, then our model should be at LOD 400. We cannot create a fabrication drawing from a LOD 300 or LOD 200. We cannot create any fabrication drawing. So if our goal is to produce fabrication drawings, then our model should be LOD 400. Okay.
Well,
So from the LOD 400 model, we will be providing the fabrication drawings. Then the works will be going on the site. And once the site work is done, construction is done, then we know probably there will be a lots of mismatches for the dimensions from the documented dimensions. Okay, for example, if there is a door, the door will may be little bit different from the drawing and the site. So we will update our LOD 400 model to LOD 500, that is the as built stage. Okay, so there is no change in detailing, but what is changing is it will update based on the actual dimension in the site. So based on the site survey, we will update our model to LOD 500, that is the as built model. So these are the different type of LODs. So LOD is actually the refinement of our model. Okay, how our model looks. So and we will choose the LOD based on the instruction given in the BIM execution plan. That is our guideline. BIM execution plan is the guidelines for a BIM project. Yeah. What is BEP? BEP means the BIM execution plan, and I already told you that this the BIM execution plan is a set of document we'll be receiving at the beginning of the project, and it actually outlines the overall BIM workflow and the responsibility means we know that there will be lots of person working on a project. There will be BIM modelers, there will be BIM coordinators, and team leads can be there. So what are the duties and responsibilities of each one? Everything will be outlined in a BIM execution plan. Based on that, every BIM project will be going on. And there are some standards. When we are working in BIM, there are some standards to follow, like for the project naming and for the component naming. We cannot name it like as we like, but there are standards. If you want to save your project, the file name should be based on some standards actually. So normally, if you are doing a CAD project, the CAD project also there's a standard to name the CAD project. There's actually a standard. So we should understand what standards are there to follow, and then comes the deliverables. These are the main things or the main points included in the BIM execution plan. Next comes the deliverables. So we are doing a BIM project. So what are the required deliverables for the client? So some clients may need IFC format, some need NWC, the Naviswork format, and the drawings. Regarding the drawings, client may need DWG format with PDF. So all these kind of the deliverable requirements will be outlined in the building execution plan, and also the collaboration process. Collaboration process means Revit has a capability of team working. For example, if there is a very large project, just imagine a large project. So we know a single person or a single resource cannot complete a large project within a limited time period. So a team, more than one member, can work in a same file. So Revit comes with a kind of capability that's actually called collaboration, but that is not a straightforward thing. There are some things to set up, like LAN setup. We should have a LAN server access or a Autodesk cloud access, and we will set the collaboration there. So what kind of collaboration needs to be set up? All these kinds of things are actually outlined in the building execution plan. So so when you are doing a BIM project, you should be able to, or you should stick on to the standards and everything, whatever it is noted on the BIM execution plan. Okay. And next important term is the IFC. So actually stands for Industry Foundation Class. Okay, Industry Foundation Class, and I, I think this also we already explained. So it's actually set up by a constitution called Building Smart. So if you Google it, you can visit their website, Building Smart. They are actually founded this standard and this file format. So is it makes the BIM more flexible. So if I do something in Revit, I can convert it into IFC, and there are some other software also, like ArchiCAD and some other software also. So from all the softwares we can export into IFC. So everyone can open it without the native software. So if someone doesn't have the Revit, but they can still view the IFC format. So this is a standard format for BIM model exchange. Okay, so these are the important terms. So before going ahead, do you have any kind of questions at the moment?
No, it's okay, sir.
Okay, okay. Now coming to Revit. Okay, so now we discussed lots of terms and things about the overall BIM. Now, so what will be the uses or the significance of BIM in the facade industry? We are all here to learn facade BIM and facade BIM modeling. So, what is the necessity of BIM in facade? So, it's just a common sense that facade is a one of the complicated industry, actually complicated industry, and which needs a higher level of precision and everything, because even a slight dimensional mismatch can lead to a lot of wastage of the materials, like glass panels or aluminum something, and which leads to very high cost, the material cost. So we should be able to foresee any clashes. Yeah. If we are just doing the conventional 2D only, then some clashes we come to
We
know
cannot
only on the
detect.
site. Yeah, we cannot foresee some kind of clashes. For example, maybe our brackets or something can be clashing with the concrete or the structural members. Uh, these kind of things we come to know only when the actual work is going on. Then a lots of reworking recurs there, and sometimes material wastage happening there, and this leads to money wastage also. So if there is BIM, we can, as I said, we will be coordinating all the models together. We will be coordinating the facade model, we will be coordinating it with the structural and the MEP model. So we cannot foresee if there are any clashes, we cannot foresee it, and we can resolve it before the site work is going on. Okay. So that is the one major advantage of BIM in the facade industry. That's the coordination of multiple disciplines. And once we have the model, we have a detailed model. For example, if we have a LOD format model, we can easily extract the necessary drawings directly from the model. There is no need of any manual drafting. We can directly extract necessary drawings. And if we consider Revit, Revit is one of the powerful BIM tool. That is not only that's not the only tool, but that is the widely used, and widely used means 80% of the industries are still using Revit. Okay, that is why we are always giving more significance for Revit because it's actually a powerful tool. So Revit has a kind of easy panel placement option. There's a dedicated curtain wall option in Revit. So we don't have to place all the elements manually one by one like that. So this is more easier in BIM or in Revit. And as I said, once the model is ready, we can easily extract shop drawings and there is nothing manual. There is no modeling is a manual part actually, but once the model is ready, then everything is automated. We can easily extract quantity takeoff of panels or mullions, transoms, flashings. We can extract the quantity of brackets and everything. And CNC support. We can directly export the step or the step file or any file format which we can directly use with for the CNC cutting or for the CNC machines. So not only from the Revit, but there are some softwares like Inventor or Reno like that. And next to another advantage of BIM is the 4D sequencing. So 4D sequencing means maybe I will show you a video. Give me a moment. Can you see my screen now? The video. So you can see an kind of animation of a construction is going on a site, right?
Yes.
This is actually called 4D simulation. So we know for every project there will be a project management there will be a project management schedule, like which work is happening first, then what is next, what is next. There's an order of works. So we can do a simulation of based on the project management chart. We can do a simulation. So for example, in the case of facade, sometimes there are situations like there will be some fixings in an location where there is no access. Such kind of things are happening in the site. We are providing the details with some brackets and with some connections, but in the site there will be there can be a column or something which prevents the access actually. So while we are doing this kind of animation, no, not actually animation, we call it simulation. For this simulation, we can see what element comes first and what comes next. So we can understand if there are any access issue to the existing element, so that we can change
Right.
our details, or we can change the
Plan.
yeah, the actually the project plan like that. Okay, so BIM help us in that way also. This kind of access conflicts and everything.
Uh,
Yeah, please.
quantity takeoff. We can take also quantity takeoff, material
Yeah,
takeoff.
yes. We can easily export, extract quantity of from the model. Once the model is done, then everything is pretty easier in BIM.
First we'll
And
complete the soft drawing, then after that we can take off the material from here.
yeah, yes. Okay, so after the 4D sequencing, it comes the reduced rework and delays. Mm. So it's already apparent that we already know the clashes and everything. So we can simply identify them before the actual work starting. So we can avoid if any reworks due to the clash, we can avoid it because we are already able to resolve all the clashes before the actual works going on. And this also avoid any delays also. Uh, okay, so these are the significance or the importance of BIM in facade. Then why Revit? Okay, we are here to learn Revit. Revit. So what is the importance or the what is the capability of Revit in the BIM industry or in facade industry? So Revit have dedicated curtain wall modeling tools. Revit have dedicated curtain wall tools. Uh, for example, if you are doing a 3D model in AutoCAD or something, we cannot see any dedicated curtain wall tools. We will have to draw everything and we will have to extrude everything. But in Revit, it comes with the curtain wall options, so it is more easy. Yeah, still there will be some manual modeling will be required, but we can still easily place the panels and everything using the Revit default options. And we can create a very complex, very parametric families. Parametric family means is something similar to the dynamic blocks you are all doing in the AutoCAD, right? So it's something similar to the dynamic blocks. So we don't have to create a lots of components for different sizes. We can add parameters inside a component. So if there is any variation in sizes, we can simply change that. We don't need to remodel the same element again and again. Instead, we can make it more parametric. So make it something dynamic. The family is nothing but all the components are called families in Revit. Okay. A
Mullion,
door or window or mullion, transom, everything. All the elements are actually
suppose
all the
Mullion we will
elements.
make in the,
Yeah.
sorry sir,
Yeah,
suppose
please.
Mullion we will make in the AutoCAD, we can import here, or we will have to make here the modeling.
Yeah, actually there's a Mullion option in Revit, but we will have to draw the profile initially, then we can reuse it. Okay.
We will have to uh, create here in the Revit, right? We cannot import the CAD file.
No, we cannot directly import it from the CAD file, but we can use the CAD file to use as a reference to create that in Revit. Okay. We cannot simply load the profile from the AutoCAD and directly convert it into a
We
Mullion. That
cannot
is not
import.
possible. That is not how Revit works. But we can just use it as a reference. Okay. Okay, so that is the parametric family say. Mm, we can we can create dynamic elements in Revit. Okay, and next comes the coordination and clash detection possibilities. So in Revit, we cannot we can uh, coordinate with other disciplines. Like suppose we are doing the facade model, so we can import or there is an option to link Revit models of other disciplines. I mean, we can mm, link the architecture model, or we can link the structural model, we can link the mechanical model. So, so we can work in a coordinated view so that, and that will help us to know if there are any clashes or something. So, Revit comes with that such options also. So that makes Revit something special when we are working a facade. Okay. So because the coordination and the clash detection is very critical. And once the model is done, mm, we can easily prepare the floor plans. We can directly prepare the elevations, vertical sections, and the enlarged detail views directly from the model. We don't need to do any manual manual drafting. Okay, directly from the model, we can easily create all the necessary drawings. So that if the model is perfect, the drawings will be error free. But as I said, the modeling is actually we are doing from our side. So model should be the perfect without any errors. Then all the drawings and uh, everything will be error free. For example, if in AutoCAD, suppose we are drawing a GA, just think that we are preparing a GA sheet in AutoCAD, and we know we will be showing the this. For example, we are showing the grid to mullion back distance in the plan view. In the plan view, we are showing the mullion to grid back, grid to back of mullion distance, and we need to show the same on the vertical section also. So in AutoCAD or in a 2D drafting, we are doing it all manually. So sometimes even I have found issues like these are mismatching. There are mismatching in the plan view, in the section view, because we are doing it manually. So there are chances there will be mismatching. But in Revit, we are doing everything from the 3D model. So every views will be matching. We don't, there is no need of any manual drafting or anything. So because we are directly creating the drawings from the model, 3D model. And also once the model is ready, we can easily create all the necessary schedule of quantities and bill of quantities and everything. And the possibility of team working. Multiple members can work on a single file. No other softwares come with this facility. For example, if you are trying to open a CAD file, if suppose multiple persons are trying to open a single CAD file, what will happen? It will be opening like a read-only file. We cannot save it. But in Revit, it comes a facility that it's actually called um, center file or shared file. So multiple persons can work on a single file. So we can easily share the workload between our team. So these are the main capabilities of Revit software, and we will go through everything in detail once we start the Revit session. Today we are just giving the basic introduction only. Okay. So now we know Revit is a powerful software, and like 80% of the industry is still using Revit as their main BIM software. But the Revit, we should be aware about its limitations also. So the major limitation of Revit is that when it is comes to very complex surface, like now we can see there are facades like in a very what to say, geometrically challenging forms, like very curved in multi-direction or something like that. So in such scenarios, Revit have some kind of limitations. And also Revit comes with precision limitation, like we cannot draw a lane or any object in Revit which is less than 0.8 mm. If there is a thin sheet with a thickness of 0.7 mm, 7 millimeters, then that we cannot draw in Revit. So Revit comes with a limitation. So we cannot directly do these kinds of things in Revit, but there are workarounds, like for the complex freeform surface, like if there is any curved facades or something, normally we will use Rhino. So there's a plugin which is called Rhino Inside. That is, we cannot, sorry, we can work directly with Rhino within Revit. So by using this plugin, we can overcome that issue of Revit to create freeform surface. Freeform surface means some complex curved facades or something. Okay. So there are workarounds, but anyway, Revit cannot directly do some things like we cannot directly draw or we cannot directly create a sheet with 0.7 mm. So in such cases, we will do that in Inventor and then we will load that into our Revit project. Okay, so sometimes we will have to make use of other softwares to create a more detailed project within Revit. So now we know the pros and the cons of Revit. Then why Revit? So Revit has lots of benefits. It also has some limitations. Then yet why we are choosing Revit? So the main thing is one is this is the very powerful BIM tool. For example, in Reno, we can create a very complex geometries. We can create uh, very challenging geometries in Reno using using Grasshopper or something. But we cannot establish the proper BIM there. So our aim is to create or is to establish a BIM model. For that purpose, we need to use BIM, Revit. Okay. So in order to achieve the BIM goal, we need to use Revit. Revit is the one of the powerful and widely used. Widely used means 80% of the industry is still using the Revit for achieving BIM models. And once we have the proper models, we can, as I said, we can easily extract drawings and schedules everything. And we know there are the revision schedules, right? For each drawings, there will be the revision schedules. Normally in AutoCAD, I think we are manually updating it, right? We are manually updating it. But in Revit, there is a dedicated revision schedule options. So it will automatically track the revisions and we don't need to update it manually. Revit, it's all more, what to say, it will happen automatically. So most of the tasks are automated in Revit and there are some advanced options like Dynamo or something. It's like additional, uh, it's not a plugin, it's kind of programming actually. So we can even make things very simpler in Revit by automating a lots of tasks. And Revit supports the parametric modeling. Like for example, if you are doing a door, creating a door, if the door comes with a different sizes, like different sizes, we don't need to create different objects, but the only one door we can make it parametric, so we can use it with varying sizes, like if the frame thickness is changing or if the what to say, if the door width is changing or if the door height is changing, we don't need to create different models. From a single model we can uh, from a single parametric model, we can change the values and we can use it with different dimensions. So that is the parametric modeling has capability. The very important thing is this is the industry standard. Every company needs Revit. If you are trying to get a job in the BIM industry, Revit is the common thing. Without knowing Revit, there is we cannot say the chance of getting a BIM job is almost zero, because that is a industry standard. Because no software has still capable of replacing it. There is no software capable of replacing Revit now and not in the recent future also. because it's already established and it has the powerful modeling and the information uh, ma- uh, information management options. Revit has it. And as I said, Revit comes with some limitations. So there are some important softwares which we will usually uh, work along with Revit to do some additional tasks. So one is the Reno Inside, which we'll be using with the Revit to create very complex facades or complex, not only facade, but we are here to learn facade. That's why I stressing on facade. So for the complex geometries, we'll be using Reno Inside. And for automating the repetitive tasks, we'll be using Dynamo with Revit. And for the coordination and clash detection, we'll be using Naviswork. And for collaboration, for example, collaboration means, as I said, multiple team members can work on a single project. So, for example, if all are working from within the same office, we can simply establish the collaboration use by a LAN setup, a server-based LAN setup. But if, uh, for example, if our team members are working remotely, like maybe someone will be working from home or something, then we'll be collaborating from the using the cloud options. So that is the ACC, Autodesk Construction Cloud, that is for remote collaboration. And we can get nice rendered views or animations from Revit using the Enscape or Twinmotion softwares. So these are not a part of Revit. These are some additional tools. So just understand these are the additional tools uh, which goes with Revit if you want to do something additionally. Okay.
Reno,
Now,
it is
yeah,
working with
please.
Revit plugin. This is
Yeah,
plugin
that's
software for Revit, or there is different Autodesk but different software.
this actually Reno is actually a different software. It's not a Autodesk product, but with this Reno Inside plugin, uh, we can do the uh, Reno modeling within Revit environment.
Sorry for the
We
interruption.
can
Yeah, please.
Can you brief me how it will be work the Rhino inside? So because I'm also using Rhino inside Rhino and Grasshopper, so I'm aware about the softwares. So if I know the Rhino inside how it will work with Revit, so very useful for me. Once you start the
Yeah,
modeling, so you can explain.
actually it's not a part of our syllabus. This was just to point. These are possible. If you would like to learn it or something, maybe you can mm, opt for it as an add-on course or something. Okay.
Okay,
If you need a demo class or something, maybe we can think about it. We can arrange it. Okay.
okay, thank you.
Yeah. Okay. So these were some introduction about the basic BIM concept and how the software works or how the software behaves. Hmm. Now, yeah, now I think we are running out of time. So I would like to go through few more things. We can, yeah. So I think you can see my screen. It's a Revit window. So do you all have Revit software with you, right? I I understand so.
no, I don't have.
Who is not having? Shano.
Channel. Yes.
Okay, okay, okay. May I know all of your companies already having any BIM projects? All of your companies already running any BIM project or something? Do you know?
Yes, yes. Yes, we have team,
Okay,
but I'm not working with that. But I have
okay.
team.
Okay, okay. What's your may I know your company name if you don't mind?
Uh, Premium.
Premium.
Yes.
Okay. Location? UAE?
No. It's Saudi Arabia. In Saudi
Oh,
Arabia.
okay. Saudi. You already sold. Okay. So do you know which version they are using? Have you ever checked that? Anyway, we will be using the 2026 version. That is the latest available now. So maybe if you are company or you are using any lower versions, there will be very slight difference. There won't be any major difference. Or if you find difficulty in any options or something, we have the WhatsApp group, or we can, if you are having any kind of questions, maybe you can ask in the WhatsApp group. Okay. So in the next session, we can address it. So at the moment, we are not going to any modeling things or anything, but let's just try to understand how the interface looks, or what is how the Revit interface, okay, and the common file formats in Revit and everything, okay. So when we are coming to Revit, there are you will hear two terms. Maybe you can see that you can see model, and also you can see families. So model is the whole project. The whole project is actually called the model or the project. And each components, for example, a building is a project, but the components used inside a project, like a door or window or a wall or a furniture, or a curtain panel or transom and everything. Each elements are called families. So yeah, maybe I can open a sample file here. Okay, let it open. Give me one moment. So maybe I think you will be hearing this term for the first time, family. We know the family. We are all have families, but this family, I think you probably hearing for the first time, right? Or have we heard it at any time? Yeah. Anyway, this is a project. I just opened a project here. So we know a project will be comprising of different objects, like we have the landscape, we have the land or the site, and we have the different elements like we have the railing. So each elements are actually called. For example, here is a window. If I select this window, you can see edit families. Actually, all the elements or the components used inside a project are actually called family. So we will have to create necessary families first, then we will be assembling everything in the project. That is how Revit works. Okay, we will have to create necessary families first, then we will arrange them in the project. So just be familiar with these terms: project or model and family. Okay, and each type of for example, the Revit project and the Revit family, everything comes with different file formats. So if you see a Revit file, how we can know whether it is a project or whether it is family? Family means the components used inside a inside a project. So the family is also a separate file. Okay, if I open this is actually a separate file. Independent of the project, it's a separate file. We will save it is a separate location. So a Revit project will be will come with the file format. Maybe I can type that in the chat. .rvt. .rvt is the Revit project or Revit model format, and .rfa. .rfa is the file format for a family. So if you ever see a Revit file, or if someone gives you a Revit file, just have a look at the file format. Maybe I can show you few file format here. Mhm. Give me a moment. So you can see these are comes with the file format .rvt. So these are the Revit project file. Okay, these are the project files, and if you now you can see some other Revit files comes with the
RFA.
RFA. These are the families. We will have to create the families first, necessary families first. Revit comes with a lots of default families, but we will have to create our own families. For example, if you are, because most of the facade elements are not a typical one, right? We will have to create our own family for panel, our own family for Mullian transom. Then we will place them on the project, and we will we will arrange everything in the project. So always be familiar with the file formats RVT and RFA. Okay.
1 minute, sir, please.
Yeah, please.
One panel will be the family, or suppose Mullion separate, it is family. Tranjam also it is family.
It's based on the type of curtain modeling. If we are doing it's like a unitized system,
Yes.
if it is a unitized system, then transom and Mullian panel, everything will be a single family. Okay.
Okay.
But if it is a stick type, everything will be separate families. Like the panel will be separate family, and Mullian transom, everything will be separate families. So in Revit or in BIM, we do the things how the actual work exactly done in the site. Okay, we will try to do maximum as possible how the exact work done in the site. But anyway, it's as I said, all the BIM projects are mainly depending on the BIM execution plan for the specific project. That is the main guideline. So we always should go through the BIM execution plan before starting a project. But as a BIM modeler, there's not a duty of a BIM modeler. The BIM manager or the BIM coordinator will be taking care of that, but they will be conveying with the BIM modelers. These are the things. So we have to do like that. Okay. So there are no strict rules in Revit, but whatever written in the BIM documents, in the BIM execution plan, that we will have to follow. So this is as I said, this is a BIM Revit project. So if you select any element, for example, if I select this window, it's not only the geometry. If we look at the properties, it comes with some values like some material specifications, like that. Okay, it comes with the material information and everything. So these are the things we said, like it can contain information also, not only the geometry. So this is the Revit window. You can see menus like file. The file menu will be containing the option to open and save and export to different formats like that. And the architecture tab will be containing to place the building components like door, window, wall, like that, stair, whatever it is. And the structural tab will be containing options to place structural elements like structural beam, column, foundations. So Revit is actually like it's a comprehensive software. It's used for different disciplines. A mechanical guy will be using for this mechanical modeling, and a structural BIM model will be using this for structural BIM modeling. So our aim is not to learn the all tools in Revit because it's a comprehensive software which includes options for the all disciplines. So we will focus on the facade elements. Okay. If you look at the systems, you can see precast options here. If you look at the system, you can see the mechanical elements here, mechanicals and plumbing elements here. So we will be mainly concentrating on the elements like mainly on these curtain walling options. You can see the curtain grid and the curtain system options here, and its related families and how to add parameters and how to prepare drawings. So anyway, from the next session, we will start basics of the modeling. So we will learn more about the user interface and everything from the next session. That is, tomorrow itself. So before winding up, do you have any questions at the moment? Otherwise, we shall continue tomorrow. So once again, what I would like to tell you a few things. Always try to be present in the live sessions rather than waiting for the record sessions. Record sessions will be there for your future references, of course, but always try to be present in the live sessions. Then only we can discuss if there are any questions or anything. Okay. And also, whatever we have discussed today, please try to find. I know you're all working, you all might be busy, but if you get any free time, try to practice whatever we are discussed today. Try to find few time to practice what we discussed before the next session, if it is possible, or at least in the weekends. Try to find some time in the weekends, because without practicing, we cannot know what we exactly know and what if do we have any questions or anything. We cannot know without practicing. So practicing is also important. Okay. Of course, we will be giving you after specific sessions. We will be assigning some small task to do as an exercise. Okay. Yeah. So, any questions? Otherwise, let's wind up today's session.
Sir,
Yeah, please.
could you send any link for downloading the Revit software expose?
Okay,
So I
okay.
can-
We'll arrange it. Yeah, sure. Our admin can arrange it for you.
Okay.
Apart from anything else?
No, sir. Thank you.
Okay,
Nice class.
so
We
okay.
are happy.
So
Yes.
you are all okay about this class because yeah, you are our new batch, the new beginning. Hope everything is clear. Or okay, always let me know. Let us know if there is anything need to improve. Okay.
Yes,
Okay.
sir.
Okay, okay. So all the suggestions are always welcome. Okay, because it's you are the main people here. Okay.
Thank you, sir.
Okay.
Okay then. Okay. Have a good sleep. Good night, everyone. Yeah. See you tomorrow.
Okay, sir. Okay. Okay.
Okay.
Thank you.
Bye. Thank you. Bye.